What's going on, Algebra 2? We have a system of three equations. Again, just some more examples worked all the way out. Hopefully the color coordination helps you. We got three equations right here with the variables a, b, and c. We got a black, red, and blue equation just for reference in the future. All right, so I'm looking at these variables and I see that we have negative 3c, positive 6c, and plus in a positive c. I know that 3, 6, and 1 all multiply together, so we can eliminate those c's really easily. So let's take a look at the top two equations, black and red, right here. I'm going to try to eliminate the c's, so we had a negative 3c and a plus 6c. Remember, we need opposite signs. We already got those, and this 3 needs to be a 6. So I'm going to multiply everything in the top by 2. And I'm going to rewrite that equation down here. So now I multiplied everything by 2. So we have negative 6a minus 2b minus 6c equals negative 16. And our c's are going to cancel. We add straight down. So negative 5a minus 6a, negative 11a. 3b minus 2b is just 1b. And then negative 4 minus 16 is negative 20. All right, so that's our green equation now. Now in the orange, we're going to do the same thing with the red and the blue, the second and third equations down here. Still trying to eliminate the c's. Well, I have plus 6c and plus c. So this blue needs to be a minus 6c. I need to flip the sign and make it 6, so let's multiply by negative 6. Rewrite it down here, and we're going to eliminate the red from the bottom blue. So these cancel right here. 3b and 24b is 27b. Negative 5a, 36a is 31a. All right, so we got a green and an orange. Now we're going to use the green and the orange to eliminate another variable. Let's use b because 11 doesn't go into 31, 1 goes into 27. Got two positives, so the top one needs to be a negative, and we need a 27 in front, so we're going to multiply by negative 27. I'm going to rewrite that green one down here. You can see the multiplication spelled out down here in the green. These cancel. The a's add up to 328a, and our constants add up to 656. I'm going to solve for a right here. There's an imaginary multiplication sign, so we got to divide by the coefficient. 656 divided by 328, a equals 2. All right. I'm going to take this a, and I can plug it back into either the orange or the green. I choose the green because b doesn't have a coefficient. It looks easier to me. So negative 11, plugging in the 2 for a from right here to right here, plus b, that's what we're trying to find, equals negative 20. Negative 11 times 2 is negative 22 plus b. Then we're going to get b by itself, so we're going to add 22 to both sides. And we see that b is also 2, coincidentally. Now we have a and b. We can plug these two variables into any of these three equations to a and b to find c. I chose the black, the top equation. No rhyme or reason, really. But it just doesn't matter, so I just chose the top one. I'm going to plug in that 2 from the a, the 2 from the b into the equation where a and b were, and we're just going to solve for c, as you can see the algebra right here. Towards the bottom, we have negative 3c equals 0. Divide by negative 3, get that c by itself. 0 divided by anything is 0. So our answer is A, B, C, 2, 2, 0. One more problem. Same setup here, different equations. Black, red, and blue. We're going to take the top two equations in green, and we're going to eliminate the a's because 3, 1, and 4 can be multiplied really easily. And really none of these go well together, so we could have done B or C. I just chose A. So right here we have the black and the red. I want to eliminate the A's, so I have positive 3A up here. That means this needs to be negative 3A, so I need to multiply everything by negative 3 to make this a negative 3A, as we wrote on the bottom here in the red. The 3A and the negative 3A cancel. Negative 3b and negative 6b is negative 9b. 4c, 9c, positive 13c, negative 23, negative 75, add up to negative 98. All right, now we're going to do the same process with the red and the blue down here for the orange equation. We have A and 4A. We're eliminating the A's, so this one needs to be a negative 4A. Got to have the opposite sign, same coefficient. So multiplying everything by negative 4, rewrite that down here. The A's cancel here for the blue and the second red. Just going straight down, negative 9B, straight down, plus 13C, and negative 75. Now with the green and the orange, we need to eliminate another variable. It really doesn't matter in this case what variable it is, because 9 and 9 go together and 13 and 13 go together. I'm just going to say we're going to eliminate B. So if we have a negative 9B down here, this one needs to be a positive 9B. So let's multiply by negative 1 and flip the sign of everything. So I'm going to rewrite this green equation down here after it's multiplied by negative 1. These eliminate, good. These also eliminate, that's coincidental. So we have 0 on the left, and the right adds up to 23. 0 never equals 23, so no matter what variables we put into these equations, they won't both be true. So since they're not true, it would be no solution. However, if we did find a B value, we would simply plug it back into either the green or the orange to find C, and then we would take that B and C and plug them in up here somewhere to find A, just like we did in the first example. This stuff is really tough. It really is. It takes a lot of practice. If you mess up early up here somewhere, it's going to screw you up later on in the equation, and that can be really frustrating. Don't get frustrated by it. I know it takes a long time, but we're just not going to do a ton of problems because I know it is time consuming. But if you do have questions, take a picture of your work. I'll probably find one small mistake early on that just kind of throws you off later, and we'll get fixing that. All right. Let me know if you need to Zoom, send me an email, whatever it is.